is Lady Leiva. I'm from Case University, Miami, and I'm going to be explaining today what is a grid. A grid is a useful tool used by radiographers to minimize the production of scatter. Scatter produces fog images, and fog images limit the visibility of the detail in diagnostic images or diagnostic X-ray. So that's why we use a grid, to reduce scatter. The grid was constructed by Gustav Bocchi. So the first grid ever constructed looks like this. You have lead strips running parallel, and then you have horizontal lead strips. This grid was called crisscross or crosshatch. The reason we use lead for the construction of the beam is because lead has a high atomic number, okay? So then we needed to improve this first one. We created a second one that looks like this. We have lead strips, parallel only, running through a grid. This is called linear parallel. We needed to improve this one, so we created a third one, okay? The third one looks like this. You have coming from the middle, you have parallel lines, left parallel lines, and then they becomes a little bit slanted to the middle also, like this. So we created this grid because the X-ray beam coming through is parallel, okay? And then they become a little bit slanted through the middle also. So this grid avoid that the X-ray beam coming through gets intersected by the left strips, okay? Otherwise, the radiation information coming through the X-ray beam gets intersected by the left strips, and that's a process that we call grid error or grid cutoff, okay? That's why we created this grid, that you have the parallel lines and then you have the slanted lead strips, okay? So we need to understand the construction of the grid, okay? So construction of a grid. How is the grid constructed? I'm going to use the linear or parallel grid so you can understand better. So you have parallel lines. These are the lead strips. And then you have the distance is called interspace. And the interspace can be made of plastic, cardboard, or aluminum. Why? Because this allows the X-ray photons to come through the interspace easily. So now we need to understand the grid ratio. So how you calculate the grid ratio? The grid ratio is calculated height over distance. So let's say we have a height of the lead strips of 200 millimeters, and then we have a distance of the interspace of 40 millimeters, and then we have the thickness of the lead strip is 10 millimeters. How you add the grid ratio? You just plug in the numbers. So grid ratio equals the height, which is 200 millimeters, over 40 millimeter, which is the distance. So your grid ratio is equal 5 times 1 or over 1, okay? So why this happened? When you use a big grid ratio, so when the grid ratio increase, the radiographic density density is going to decrease. So to compensate for this loss, we need to increase the MAS, because the amount of X-ray photons decrease the MAS, decrease the density. So how we calculate this? We have a standard by the ART or grid ratio. ART, how to calculate the mass that we need to use. So it's the grid ratio. And then versus that, we have the grid conversion factor, the GCF. Okay, so without a grid, we multiply that by 1 MAS. With 4, 1 or 5, 1, we multiply that by 2 MAS. With 6, 1, we multiply that by 3 MAS. With 8, 1, we multiply that by 4 MAS. With 10, 1 or 12, 1, we multiply that by 5 MAS. And with 16, 1, we multiply that by 6 MAS. So that's how we calculate how much mass we need to compensate for the loss of X-ray photons. So now come with me to the lab so I can show you how the grid error is produced. So I'm going to be explaining today the different type of errors, grid errors that we can create. This is a very simple one. We have a grid right here. This is a grid. We have a blue label, okay, and we have a line. This means that the grid should be facing up. If we put the grid upside down, that's going to create an error called upside down grid. So let's see how it works. You have your film right here, okay? You already collimated, we already positioned, we already dented, everything. So we're going to place the grid upside down to see what happens. So we place the grid upside down and we get the body part. We place it. When we're done with this film, how it's gonna look, the image is gonna have lack of density on the edges, so you're gonna see light on the edges, and then on the middle you're gonna see really dark, like 3 lines, 2 light and 1 dark. That's called upside down grid. So the second error is called a double grid error. We all know that we use a grid when we have a thicker body part, more than 60 kVp we use, and 10 centimeters. So where the error comes from, here in the body we have already a grid, and then we're gonna place one in the table for bodies that are really thick. So the error comes from, we have 2 grids. In order to align the lead strips of each grid is really hard. So we have parallel lines in the middle and then a little bit slanted from the sides. In order to align those sides for both grids is really difficult. That's why we get the double grid error. Even though we need double grid because the patient is really thick, we will get that error in the image. The third error I'm gonna be explaining is the off-center error. This happens when you don't align the grid correctly. Let's say the grid is aligned right there. If you move the grid and you don't align it with the table and the X-ray tube, that will produce, when you get your image, it will produce an off-center image. You will be missing part of the image. The fourth error I'm going to explain is the off-level error. This happens when the angulation of the X-ray tube is not right. It's not set up correctly. So we have a button here that says angle. If we angle it to the side, that will produce elongation. So our image, let's say we're doing a skull, our image, the chin is gonna look elongated. That's off level. The fifth error I'm gonna be explaining is the off focus errors. This happens because the SID, which is the source image distance, is not correctly set up. As we can see here, we have a small SID, so we need to increase SID in order to decrease magnification, which will decrease the distortion of the image, which is the ideal image that we want. So we got it vertically, we got it up to 40 SID, and that will give us a perfect image. I'm going to be explaining now the different images that we took in the lab. So the first image that we see here is the air gap technique. The air gap technique is used to increase the OID, so we decrease the amount of scatter that reach the image receptor. The second image is a double grid. A double grid is, you see the zebra patterns. That occurs because of the less strips of each grid interface one each other, and that's how we get a double grid error or Moiré effect. So the next error that we can get is off-center. Off-center happen because of the misalignment of the grid. We can call it also lateral decentering. The next error, as we can see, we have like a shadow or a penumbra. That's called off focus. Off focus happen when the SID is not aligned into a range that it should be. Okay? So the next image that we can see here, the skull, it looks elongated. That's called off level. That means the X-ray tube is angling incorrectly. Next image we see lack of density right here, and then we have a really black straight line. That happened because the grid is placed upside down, so in reverse. So the label and the line in the middle is placed upside down. So that's create this error, upside down error.